Previously, we've been looking at indices, and indices give us a background on logarithms. Now, John Napier used indices to come up with logarithms. In this video, we get to introduce ourselves to logarithms. This is Kisembo Academy, and thanks for tuning in. Right on your screen, you see 10 to the power 5 is going to be equal to 10 times 10 times 10 times 10 times 10. We earlier said that this power 5 means that this 10 has been multiplied 5 times. And the answer we are getting here is 100,000. Now, if we are to find the logarithm of 100,000, the logarithm of 100,000 is going to be equal to 5. That is, if that logarithm is to base 10. Why do we say so? Because you're going to have to raise 5 to base 10 for you to be able to get 100,000. By saying all that, I'm trying to derive the definition of logarithms. In essence, the power to which 10 must be raised in order to give 100,000 is called the logarithm to base 10 of 100,000. So it means the log of 100,000 is going to be 5 base 10. And that is the definition right on your screen. Take a look at this number. This is 100,000. From our definition, what is the logarithm of 100,000? Now, the logarithm of 100,000 is going to be the power to which 10 must be raised for us to be able to get that 5. If you look at 100,000, it is 100,000, meaning it's having 1, 2, 3, 4, 5 zeros. Now, to what power should we raise 10 so that for us to be able to get 100,000? Of course, we are supposed to raise 10 to the power 5. If we raise 10 to the power 5, then we'll be able to get 100,000. So, that power to which 10 must be raised in order to give this 100,000 is what we are calling the logarithm to base 10 of that number. So, meaning that the logarithm of 100 to base 10 is 5. That's why here that the logarithm of 100 to base 10 is going to be 5. Now take note that this has been to base 10. So let's look at other illustrations. Now, what is the logarithm of 16? Here the logarithm of 16 is going to be 4, but this time it won't be to base 10 because it is 2 to the power 4. So you're raising the power 4 to a number 2, not to 10. So the logarithm of 16 here is going to be 4 base 2. That's why we are saying that the log of 16 is going to be 4, but it's to the base 2. So let's do a few examples. What is expressed in the form of logarithm? So what's the log of 8? Simple. The logarithm of 8 here is going to be 3. But what's the base of the logarithm? It's 2. So it's base 2. Likewise here, what's the log of 1? So the logarithm of 1 is going to be 0, but it is to base 10. Getting on to our next illustration, converting this number to logarithm, the logarithm of 3 is going to be a half. So it's going to be a half, but it is to base 9. Likewise here, the logarithm of this number 5625, the logarithm of 625 is going to be equal to 4, but what's the base? 5. As simple as that. Now, if you look at these numbers that we've just done, these numbers and this number, if you have to try and convert them back to index form, this is the pattern. So the pattern here will be 2 to the power 3 is supposed to give us 8. 2 to the power 3 is equal to 8. And this one takes us back to this. Likewise here, 10 to the power 0 is equal to 1. 10 to the power 0 is equal to 1. It takes us back to that. In the same breath, we are going to convert these numbers to index form. They're telling us that the log of 8 base 2 is equal to 3. Converting that to is still going to be, we shall say it's 2 to the power 3 gives us 8. So 2 to the power 3 is going to be equal to 8. As simple as that. Now we've converted this logarithm to index form. It's the same thing we shall do here. 10 to the power 0 is equal to 1. Then also, just like before, it's going to be 9 to the power half is equal to 3. And also here, it's going to be 5 to the power 4 is equal to 6 to 5. So it's 5 to the power 4 giving us 6 to 5. So that's how you're going to juggle between logarithms and indices. You can convert an index into a logarithm and return it back to where it was. That brings us to the end of this video. Thanks for tuning in. Up next, we shall be looking at properties of logarithms. Thanks for tuning in. I encourage you to subscribe and share this video. This is Arnold Rangakuramya for Kisembo Academy.